Okay, this is lesson 18, and we are going to continue working on comparing two populations using sampling. So remember, when comparing two populations, we want to know what measures of center of variation the question is asking us to find, and then being able to find those measures and actually answer the questions. So remember, when it asks us to compare, we need some kind of sentence for our answer. Okay, so let's go ahead and do example 1. It says, here are dot plots showing the weights of backpacks for a random sample of students from the 2 grades. So we've got grade 7 and grade 10. It says, do 10th grade student backpacks generally weigh more than 7th grade student backpacks? So in order to figure this out, we first need to kind of understand our measure of center. So remember in the last lesson, we talked about to find our measure of center, just kind of taking our pointer fingers and putting them at either end of the data and slowly bringing them both to where they might meet in the middle. So for grade 7, I would say they probably meet around 7. So we're going to say 7 there. For grade 10, we're going to do the same thing. Bring them to about the middle of the data. We're going to say around 16 pounds. Now, we also need a sentence. So we're going to say 10th grade backpacks tend to weigh more than our 7th grade backpacks. And let's add in a little bit more information. We'll say by about. £9 pounds, which is the difference between 16 and 17. Our next question says, is there a meaningful difference between the weights of 7th grade student backpacks compared to 10th grade students' backpacks? Explain. So remember we talked about meaningful difference in the last lesson. Just has to do with whether or not there is a difference of overlap, so some kind of space between our data. So if we look at grade 7 and grade 10, they only really overlap about right here. So most of the data is pretty spread out from one another. So they do not overlap a ton, which means that there is meaningful difference. So we're going to say yes, because there is little overlap. All right, next page. So example 2, it says, the double box plot shows the data of test scores for 2 classes. Which class test scores are the most spread out? So remember, the more spread out it is, the larger the range. So we first need to find the range. So we're going to find the range for class A and the range for class B. So maximum minus minimum. So here's our max value for both of them, actually. So we're going to do 100 minus 76. Just going to give us 24. Then we're going to do 100 minus 68, which is 32. So class B has the larger range. So we would say that class B, because there is a larger range. And we're going to be even more specific and say there's a larger range by about 8 points. which is the difference between 32 and 24. All right. What is the difference of the interquartile range for the two classes? So since these are box plots, we can find this information. Let's go ahead and just label our 5-number summary on our chart, which we probably should have done before we answered the first question, but we're going to just do it now. So I'm going to label both of them. So remember, our 5-number summary has to do with our minimum, quartile 1, our median, quartile 3, and the maximum. So we need the interquartile range. So we need to show our work for both Class A and Class B and answer the question. So Q3 minus Q1, so 92 minus 84 is going to give us 8, and 84 minus 76. That actually is also going to give us 8. So we're going to say that they are the same. There is no difference. So overall, which period did better on the test? Well, if we take a look, Class A, their minimum score was a 76. So overall, Class A did better. Overall, Class A did better on the test. And using our knowledge of quartiles, we could actually say that over 75% of them scored above an 84. Got at least an 84. Whereas if we compare it to Class B, 75% of the students got only above a 76. So remember, each section is 25%, so 25%, 25%, 25%. All right, next example. It says, these two box plots show the distances of a standing jump in inches for a random sample of 10-year-olds and a random sample of 15-year-olds. I want you to go ahead and try this one on your own. So it says, which of the following is a true statement about the box plots above? So you're going to have to find some of the values. So please pause the video, try this one on your own. When you're all set, unpause and just check your work. All right, you should have some work off to the side of the paper. They're asking you about the medians and the interquartile range. So remember, for your box plot, go ahead and label. So minimum, quartile 1, median, quartile 3, and the maximum. So minimum, quartile 1, median, quartile 3, and the maximum. So for my interquartile range, for the 10-year-olds, I'm going to have 58 minus 53, which gives us 5. And for the interquartile range for the 15-year-olds, I'm going to have 70 minus 65, which is also 5. So they have the same interquartile range. So let's just look. That cancels out the options A and B. And then our median. So 15-year-olds have a larger median. So 15-year-olds have a larger median. That one is C. Example 4. Box plots show the distribution of the number of team wristbands sold daily by 2 different stores over the same time period. Which statement is true about the range of the number of wristbands sold daily for the 2 stores? So we need to first find the range. I'm going to let you pause the video, try it on your own. When you're all set, unpause and check. All right, so you should have 75 minus 25. So remember, we need to show our work. That's going to give you 50 for store A, and then 73 minus 42 is 31 for store B. So the range for store A is greater than the range for store B. Example 5. A principal gathered data about the distance in miles that his teachers and bus drivers live from the school. The box plot shows the data sets. Based on the box plots, which statement is true? So it says the interquartile ranges. So we need the information about the interquartile range or the range. So I'm going to have you find both of those things for the bus drivers and the teachers. Please pause the video when you're all set, unpause, and check. Okay, so interquartile range for my bus drivers. Remember, quartile 1, quartile 3. So I've got 20 minus 10. For my range, I'm going to have 30 minus 5, which is going to be 25. For the interquartile range for the teachers, I'm going to have 30 minus 15, which is 15. And then my range, I'm going to have 35 minus 5, which is 30. So both the interquartile range and the range are larger, but I think it goes through and gives you a little bit more detail. So it says that A, the interquartile range of the distances for bus drivers is twice that of the interquartile range of the distance for teachers. That is not the case because it is not twice, so we're going to cross that one off. B, the range of the distances for the teachers is twice the range of the distances for the bus drivers. Well, the range is a little bit higher, but it's only higher by 5, so it's definitely not twice as high. C, the interquartile range for the distances for the bus drivers is 5 miles less than the interquartile range for the distance of the teachers. Well, 15 minus 10 is going to give us 5, so it could be C. Let's double check letter D. So the range for the distances for the teachers is 5 miles less. Well, we know that's not true because teachers have a higher travel distance. So our answer should be C. All right, that's all for this lesson. Good luck on your homework.